Okay, my Cal 2 students, this right here is for you guys. We're going to find out when can midpoint, trapezoidal, and also Simpsons rules give exact answer to an integral that we're trying to approximate. And yes, this is possible. It depends on what kind of function that we are dealing with. And let me tell you, this and that, we can just do them geometrically, but for the Simpsons rule, not so much. It's okay though, because remember, we have the error bounds formulas for all these three. So that's what we're going to use to solve this question. We're going to find out the condition on f so that this, and that will give us exact values. Well, let me write it down right here for you guys. Let's look at the error bounds. Now, the main thing is that we have to look at the k. That's the only thing that we have to do with the function. So I'll write this down right here. What is k? K is a number so that the absolute value of the second derivative of the function, it has to be less than or equal to k right here. And of course, we are just talking about the interval from a to b, so I will just tell you for the x values in between of a to b, it just has to be on this interval. That's all. Well, suppose a is not equal to b, and suppose just pick whatever n that you want for the same for both of them. Now, here's the deal. How can you make this 0? Why 0? Because, of course, when you have no error, that means exact answer. So you want to have this and that being 0. And if you can pick k to be 0 now, then that'll solve the question, right? So based on this and that, what you want is the following, right? Look at, you want this k right here, and this k right here, and this k right here, of course, same thing. What you want is, you want the k to be 0, so that you can see this is 0, that's 0. And what you need to solve now is, you put k equals 0 right here. In another word, you want to have the absolute value of the second derivative of the function is less than or equal to 0. And because you're talking about the absolute value, so that means this is not going to be negative. The only way this inequality is true is when you have the second derivative being exact 0. So in another word, you really want to have the second derivative of the function to be 0 on this interval. So I will just tell you guys for the interval for the x value from a to b. This is the condition. You want the function so that second derivative to be 0. And now think about for what function that you can get another second derivative of that function will be 0. And the answer to that is linear function. How do we know? Well, I'll show you guys real quick. First, you integrate, right? Technically put on dx. When you integrate second derivative, you get the first derivative, and that's f prime of x. And on the right-hand side, you get a constant. Don't forget about that. Let me just put down c1 for the first constant. And then you integrate again. And you should still put on dx. Well, when you integrate the first derivative, you end up with the original function. So you have f of x. And now on the right-hand side, you get c1 times x plus c2, right? As you can see, if the function is linear function, then its second derivative will be 0. That means the k will always be 0. That means you will never get any error because you will get the error being 0. So that means this and that will give you exact answer. So let me just tell you guys this right here. And technically, I will write down f of x has to be a polynomial. Technically, this is a polynomial with degree 1 or less, right? And this right here will guarantee that m and n for m n and tn will give you exact answer. So this is for m n tn, right? So this right here is the answer for that. And of course, you can also say linear function if you would like, but I will also say polynomial with degree 1 or less, because I'll be using the similar language for later on. Anyway, let me just show you guys real quick why with a picture. So imagine if you do have a linear function, of course, if you graph that, you'll just get a line. And let's say here is my A and here is my B. And I just want to do a demonstration, so I will do n equals 2. All right, imagine this is your f. I want to use n equals 2, so I'll just cut this right in the middle, right? So I have these two intervals to look at. And look, I have one trapezoid and two trapezoids already, isn't it? So that's good. Of course, Tn, if you put another trapezoid and another trapezoid there, of course you'll be exact. So that's it. By the way, if you happen to have a horizontal line, meaning when you have a function being just a constant function, well, in that case, technically, when you use the trapezoidal rule, you begin to draw rectangles because how the formula is defined, right? But anyway, let's look at the midpoint because it's not so easy to see. But don't forget the midpoint is that you look at the middle between this and that, which is that is right here, and then you are going to go up, and then you are going to make your rectangle once you hit the curve right here. And yes, you see that this part is sticking out, but this part is missing. And the truth is that they have the same area, meaning that if you just take this part and fill it in, you get perfect. Likewise, of course, if you do it again right here, go to the middle and then hit the curve, which is just a line, and you make a rectangle. You can take this part, fill in there. In fact, you still end up with the exact area. So midpoint and trapezoidal will always give you exact answer when you have a linear function, polynomial with degree 1 or less, right? Now, for the Simpsons rule, it's kind of different. And remember, for the Simpsons rule, the idea is that you're going to use parabolas to approximate curves. But the answer is not second degree polynomial. It's not a quadratic function. You'll see. So let me write it down right here for you guys. E sub s. This right here is slightly crazier, but it's not that bad. K times b minus a to the 5th power, and then you have this over 180, and you have n to the 4th power, like this. In this case, again, we'll focus on the k value because this is the only time you can make the connection between this and the function, right? The formula and also the function. I will just tell you, k is a number where that the fourth, this is the fourth derivative of the function. It has to be less than or equal to k on the interval, of course. So I'll just tell you guys for x in between of a and b on that interval. And of course, again, we are assuming a is not equal to b, otherwise it will be boring. Well, in this case, again, you want this k to be 0, so you can have no error, meaning 0 error right here. So in this case, I'll just put down what we want is k to be 0. And again, you are saying the absolute value of the fourth derivative of x has to be less than or equal to 0. So what you really want is the inside to be 0 on this interval. So I will just tell you we want the fourth derivative to be 0 on the interval a to b. So I'll just tell you guys for x in between of a and b. And now you just have to think about what function has fourth derivative being 0. And the answer to that is a cubic function. It's a polynomial with degree 0 or less. Similar to that, I will leave the integration on your own. Well, I'll just tell you guys the answer to this right here. F of x has to be a polynomial with degree 0 or less. So it's the same language of that. And this right here is for the Simpsons rule, right? So these are the conditions on the kind of function so that this right here will give you exact answer. Of course, this right here is the best, right? Pretty cool, huh? Let me know if you guys have any questions. Leave a comment down below. And if you haven't subscribed yet, what are you doing, right? Anyway, that's it.